On the prior two examples, we were given some right triangles and asked to find either the length of the leg or the hypotenuse. In this final example, we're going to use something called the converse of the Pythagorean theorem that helps us conclude whether it's a right triangle or not. So we're going to be able to prove whether we have a right triangle given three sides of a triangle, or whether we don't have a right triangle based on this idea of the Pythagorean theorem. What we do know is, if it is a right triangle, then the longest side squared, or hypotenuse squared, has to equal the sum of the two shorter two sides squared. So if that comes up to be a true statement, we know we have a right triangle. If it comes back a false statement, then we know that it's not a right triangle. So we're just applying the same knowledge, only in a little different light. So the lengths of the three sides of the triangle are 5, 7, and 9. Determine whether the triangle is a right triangle. Well, I know the 9, if it is a right triangle, has to be the hypotenuse. So in our formula, c squared equals a squared plus b squared. If this is actually true, if this actually comes back to be equal, then we'll know we have a right triangle. If it doesn't, then we know it's not a right triangle. So the longest side squared is 9. Does it equal the shorter two sides squared, so 5 squared and 7 squared? So is the 81 equal to a 25 plus a 49? And a 9 and a 5 is a 14. Carry the 1, that is a 74, and 74 and 81 are not equal. So I'm going to write that over here to the side. I ran out of room. So 81 is not equal to 74. So therefore, it is not a right triangle. So we'll apply it to another one. We got 9, 12, and 15. If this is going to be a right triangle, then 15 squared will have to equal the two shorter sides squared, 9 squared, and 12 squared. So 15 squared is 225, 9 squared is 81, and 12 squared is 144. So if we add up our 144 and 81, that's a 5. That's 12. Carry the 1. We got 225 is equal to 225. So since this came back as a true statement, what we now know is that it is a right triangle. This is called the converse of the Pythagorean theorem. It's used to help us determine or to prove if it's a right triangle or not. Pretty simple to calculate. Just make sure you know what you're looking for. If they're equal, it is a right triangle. If they're not equal, it simply is not a right triangle. That's all that we can determine at this point.